Hello guys and welcome to my channel The Bio Guru, where science becomes sick. Today's lesson will be about the link reaction, which is the stage of respiration that follows glycolysis. Now I must tell you that if you want to fully understand the link reaction, then you should definitely have a good understanding about glycolysis. And I believe my previous video on glycolysis can help you in doing that. So without any further ado, let's move on with our lesson for today, which is the link reaction. So the 3-carbon pyruvate molecule produced from glycolysis enters the matrix of the mitochondrion. So in basic terms, the matrix of the mitochondrion is where the link reaction occurs. Or in other words, the mitochondrial matrix is the site of the link reaction. Now once the pyruvate molecule, which has 3 carbon atoms, enters the matrix of the mitochondrion, it is converted into a 2-carbon molecule which we call the acetyl group. This 3-carbon pyruvate molecule is converted to a 2-carbon molecule called the acetyl group. Now during this conversion, decarboxylation occurs. As the name suggests, decarboxylation is the removal or elimination of carbon from a compound. And in this case, 1 carbon atom from the 3-carbon pyruvate molecule has been eliminated to form the 2-carbon acetyl group. So for easy reference, I have outlined this circle in blue, and this circle in blue represents the carbon atom that has been removed or eliminated or decarboxylated during the conversion of pyruvate to the acetyl group. So whenever decarboxylation occurs, the removed carbon forms carbon dioxide. And you need to know how much carbon dioxide is produced per glucose molecule. So 1 molecule of carbon dioxide is produced per pyruvate molecule, because since 1 carbon atom is removed per pyruvate molecule, that 1 carbon atom forms 1 molecule of carbon dioxide per pyruvate molecule. So from glycolysis, you should remember that 1 6-carbon glucose molecule gives rise to 2 3-carbon pyruvate molecules. Therefore, if 1 carbon dioxide molecule is produced per pyruvate molecule, then we need to multiply that number by 2, and therefore per glucose molecule 1 times 2 carbon dioxide molecules are produced, which is basically 2 CO2 molecules per glucose molecule. So 1 CO2 molecule is produced per pyruvate molecule, or you can also say 2 carbon dioxide molecules are produced per glucose molecule. Now that we have looked at decarboxylation, let's see what else happens during the conversion of 3-carbon pyruvate to 2-carbon acetyl group. Another process that occurs in addition to decarboxylation is dehydrogenation. Now from glycolysis, you should already know what dehydrogenation means, because I have explained it in detail in the previous glycolysis video, which you can check out on my channel. But I'll repeat the definition. So dehydrogenation, as the name suggests once again, is the elimination or removal of hydrogen. And therefore when hydrogen is removed, hydrogen is released, and this released hydrogen cannot be kept on its own. Therefore, it is accepted by NAD, which is a coenzyme. And according to chemistry, when a compound gains hydrogen, it becomes reduced. And therefore, when NAD gains hydrogen, it forms reduced NAD. Once again, 1 molecule of reduced NAD is formed per pyruvate molecule, and since 2 pyruvate molecules originate from 1 glucose molecule, 2 times 1, which is 2. So 2 reduced NAD molecules are produced per glucose molecule. I repeat, 1 reduced NAD molecule is produced per pyruvate molecule, and so 2 reduced NAD molecules are produced per glucose molecule. Alright, so now that we know what exactly happens to cause the conversion of pyruvate to acetyl group, let's look at what happens to the acetyl group once it has been formed. So this 2-carbon acetyl group combines with coenzyme A. Now this coenzyme A is usually abbreviated as capital C, simple O, and capital A. So this 2-carbon acetyl group combines with coenzyme A, or CoA in short, to form a compound known as acetyl-CoA. And after this, the coenzyme A transports the acetyl group to the Krebs cycle, or the citric acid cycle. Now we will be learning about the Krebs cycle in our next lesson. So this is it for the link reaction. So to summarize everything what I just said, the 3-carbon pyruvate molecule, which enters the matrix of the mitochondrion, is decarboxylated to form the 2-carbon acetyl group, during which carbon dioxide is produced. And in addition to decarboxylation, dehydrogenation also occurs during the conversion of pyruvate to acetyl group, causing the production of reduced NAD. And this 2-carbon acetyl group then combines with coenzyme A to form acetyl-CoA and is then transported to the Krebs cycle, or the citric acid cycle, which is our next lesson. So that's it for today, guys. Hope you all got a thorough understanding about the link reaction after watching this video. If you did, then make sure to like, share and subscribe. If you have any doubts or clarifications about the lesson, then please drop them down in the comment section and I will try my best to answer all of them. Thank you all for watching this video and see you soon in our next lesson. Bye.